Welcome to the Boiling Point. I am Richie WARE, and we are on location. Actually, the first time that we've been on location. We're down in Oklahoma, in Owasso, Oklahoma, down here at Victory Energy. Now, Victory Energy is a boiler manufacturer making Firetube and water tube boilers, HRSGs, a lot of different things. Of course, been around for a good while. This is Orrin Hardesty. Orrin Hardesty, known you for, gosh, over 20 years now.
Right.
So what do you do here?
I'm the National Sales Manager for the Frontier product line. So taking care of assisting the regional sales managers, help developing, our product for the Frontier product line.
Yeah.
Support arm for all of our reps as well, out in the U.S.
Right. So he's a manager, salesman, of course, but understands the manufacturing process very well. And again, as a company, we use the Victory Energy line for our rentals, something that we went out to find a really good company that we could depend on, because when those rental boilers get there, we've got to get those things to work, right? So and last a long time. So what I thought we'd do today, though, is I wanted to go back into these stages that they actually build these boilers, and Orrin is going to explain each one of the stages, and you'll be able to see a little bit about how a fire tube is actually manufactured, and we'll touch on some technical things of that. So let's go to stage one.
All right.
So we're down here in stage one of the process, and you've actually got 5 stages that you actually go.
That's correct.
So this is a 2,500 horsepower boiler right here. Pretty good sized boiler.
Yes,
right?
He's a big one.
Yeah. This one's not ours, but most of the other ones that we are going to be talking about are ours that we are going to be using on the rental fleet. So, but Orrin, why don't you just take us to the process of stage one? What actually happens here?
Stage one is where we actually will begin this process of incorporating tube sheets, turnaround, furnace, welding in all the stay rods, welding all the connections to the boiler, making it the major welding process is being done in that stage one to create that pressure vessel.
Okay. So now, as far as putting the stay rods in, what actually does a stay rod do?
Stay rod, anytime by ASME code, section 1, any void area that doesn't have already an anchor, such as a tube joint, that bare space needs to have another anchoring point to make sure there's no implosion to that area.
Okay.
That is void of any kind of an anchor on that tube.
So you're basically trying to keep that tube sheet from warping.
That's
what
correct.
You're doing. Okay.
And with the buildup of pressure internally, with water being on the outside of the tubes and have a large capacity there, you've got a very large area that has to be when it's in a flat. That's the critical part of a stay rod, making sure that flat area that doesn't have an anchor is secured.
Right. So the tubes actually are through the tube sheet here, so that's really an anchor?
It is.
Right?
It really is with that joint. It's creating an anchor point for that area of the tube sheet.
So I noticed on this particular one, you've got the front tube sheet, the rear tube sheet is not in yet.
Not in yet.
But there is something in the middle there. What is that?
When we get boilers that start to exceed 20 feet from inside tube sheet to tube sheet, we like to have what we call an intermediate tube sheet.
Okay.
This just gives the additional support for the weight of that tube, with that long distance. It's just making sure we have no droop with that tube on a length that long.
Yeah, definitely don't want any sagging.
It's not a pressure requirement. It doesn't require the thicknesses like we do on our main tube sheet. So you can get by with a thinner wall, 1/2 inch, 9/16, whatever you want to use, because it's strictly just an area for the tube to rest.
Okay. So when we're talking about the tube sheet, I guess number one, this thing is thick. What are we looking at here?
This is a 7/8 material for this tube sheet.
Awesome. And as far as the tubes themselves, they actually go in these holes, but I'm noticing that you have some type of a groove in here.
We call that a serration. This has really been established more from the industrial boiler world. Water tube designs, that's kind of a standard practice. We wanted to make sure that besides bringing on a well above ASME code section 1 material wall thickness for the tube sheet, with ours our minimum is 3/4 to 7/8 usually, but with this serration it just adds an additional way when we roll that tube in that process. Part of that outside wall goes into this very It's just a 1/16 by 1/16 dip, a deep serration in that tube hole. And what that does, it creates an additional strength in the tube pull process. So imagine this boiler, when it's firing, it's got to grow horizontally. So you've got a lot of pull going on with those tubes to that tube sheet. This allowed an additional 41% additional strength to that tube pull process.
Right.
So all that said, it just gives you a very durable joint for the tube to the tube sheet for that, because it's really your heart and soul of a Firetube boiler. If this isn't designed correctly, that's where you get into issues with cycling conditions, things like that can cause that stress to that tube area.
So last thing on the tube sheet here, we got a pretty good sized hole here, and this is where the Morrison tube, of course, is going to be put on. Now this is done in this stage 2. Is that one?
Yeah, no,
Morrison
actually,
tube?
this will
Or you
happen
gonna
in
have it here?
stage 1
Okay,
too.
Okay.
Because with this process, we have to get the initial tube sheet set, aligned,
Gotcha.
properly set up, and get the stays in. Because once you put that hole, we'll actually build the rear and that turnaround section and furnace all will be as a unit.
Okay.
That'll slide in from the rear of the boiler to where we then get that alignment correct, because you don't want to have these tube sheets off.
Right. Right.
then you have those concerns with, getting that aligned and getting them to seat.
One thing I noticed is, why is this at an angle?
You got a 28-degree bevel typically, both on your furnace area and also on the tube sheet. This allows the proper amount of passes and weld width based on pressure as well as the thickness of that material. There's a code requirement about how much weld will need to be put into place to properly secure that furnace and tube sheet to the shell.
Now, is there some inspection stuff that's going on while all of this is happening?
We have a very strict ITP that's being followed, so there are hold points, inspection points throughout this process with travelers, what we call travelers. That is a form that both our welders, our certified welders that are set up to do this process, along with our inside quality control personnel and our third-party Hartford insurance inspector that will all have to review, inspect, sign off before the next process will move forward.
Yeah, pretty important to have all that stuff. I mean, just from the standpoint, these things obviously are could be very dangerous if not built well.
Absolutely. You can't skip a pass or anything like that to try to get this thing through the system.
Yes. No.
There's too many checkpoints to make sure by code that we have to follow and inspect.
Awesome.
So, very durable.
Well, let's move on to stage 2. Okay, we're on to stage 2, and this is actually a 650 horsepower. This is one of ours. It's going into our rental boiler. So we've got the tube sheets, and now what happens?
Right now, all the main welding from stage 1 has been done. You can see now we have our Morrison tube already in place, finally welded out. Everything's finalized, tube sheets completely done. Now this is where we actually stage for putting tubes inside the boiler, getting those fit, set into place, then the process of cutting one end, making sure that we leave the proper distance on the end for proper expansion, roll, and bead process for this joint to secure this. Now you can see on this product the inlet going into the second pass of tubes, we do a fillet weld to help secure the heat transfer, because really that's what that process is about. It's not really, people used to say a seal weld. Don't like that terminology. This is really a fillet weld, a one-pass weld that actually helps the heat transfer from that tube sheet to the actual tube, just to get that release from that, and to avoid burning any kind of ends. If there was any kind of length of flame or something like that, or flue gas erosion. So. And now
it's very critical that these are not too long.
Absolutely.
That stick out, right?
We typically have a 1/16 of an inch typically sticking out from that for a final when we're doing our weld process. Now, if it's a expand, roll, and bead, Typically you have about a 3/16 long distance there outside the tube sheet. Then that allows a nice clean bead when that beading process, because we use what we call a 3-in-1 tool,
Okay.
Wilson tool. It allows this process, which in the old days you used to have a separate beater,
Yeah.
right? You
Yeah.
expand the bead, then you take a beater,
Yep.
mandrel, and run at it, and it was like a jackhammer. It was very loud and noisy. Well, now the 3-in-1 tool does it all in one process.
Okay.
So when it expands the tube, gets it to the proper expansion, then it begins that rolling over of the tube end to the tube sheet.
Yep.
The important part with a bead process is getting that bead tight
Yep.
to that tube sheet, right? So if you get too long, it either gets too wide and it isn't able to roll that bead over or that tube over to the tube sheet very well.
Okay. Now I'm noticing that number one, the tubes are XID tubes, which means there's a rifling, a rib in there. What is that actually doing?
The rib allows the flue gas stream, when it comes from that furnace, turns around, goes through that tube. Typically on a bare tube, it'll strike the first 2 or 3 foot, then it goes linear.
Yep.
You know, it just goes flat through that tube. So you don't get the transfer in a bare tube like you will a rifle tube. It creates turbulence
Yep.
through that tube throughout the entire length of that tube through that boiler. So it strikes and we get that great heat transfer in that boiler. It increases your fuel to steam thermal performance tremendously.
Sure.
Anywhere from 2 to 3% gain by using a rifle tube like that.
And as far as kind of the same thing here, we've got a corrugated
Absolutely.
Morrison tube, right? There's boilers that are straight and flat, and then there's boilers that have the corrugated.
You know, the nice thing with us, we give alternatives for this. There are some customers, believe it or not, they like a plain furnace,
Yep.
you know, for their boilers, but there are several that demand a Morrison tube. The advantage of a Morrison tube is it allows that good heat transfer again. Also, you get by with a thinner wall per ASME code because of the rigidness, you know, the ridges that you have throughout. That creates that additional strength
Okay.
to make up for the wall thickness you would have to have for a plain furnace.
Awesome.
Now
Okay.
what that allows, you get into high pressure boilers like this. This is a 250 PSI design boiler.
Yeah.
If that was a plain furnace, this would probably be another 1/4 of an inch thicker material
Okay.
to comply to meet the requirements of ASME Code Section 1.
Okay. Now, again, this is a 2-pass. Just a quick question, all right? Just maybe some people might even want to know this, is why is the actual Morrison tube itself, why is it down at the bottom and not in the middle?
Typically on a 2-pass boiler, you know, you like that lower position furnace to allow that hot source being at the bottom. It creates a natural circulation inside the boiler to create that circulation required so we don't have any stratification in the water.
It's a big word for me.
That creates hot pockets.
Okay, all right, hot pockets.
Okay, that would actually cause problems with that tube or maybe even the tube sheet area.
Okay.
Typically, a lot of failures that have occurred with certain products happens in this lower section, the hottest section of that. If that circulation isn't good within that boiler, tubes too close, because that's one thing we haven't hit on is our ligament spacing.
Space, yeah.
We paid close attention to that when we designed all of our Frontier product line. I wanted to make sure that when we developed this, that we maintain a 3/4 inch minimum between each tube hole here.
Okay.
That just allows that circulation to properly filter through all those tubes
Yeah.
with its natural circulation. You start getting these too close, now you may have concerns with this circulation process in this boiler.
Gotcha.
So with your inlet of your feed water, we create a little diversion plate that creates that natural circulation to get that started. And then with your natural heat of that hotter source down there, it just generates that circulation throughout that boiler.
Perfect. No, great information. Let's move. One other thing that you do that we absolutely love is for the door.
Yeah, this davit arm, guys, we take this very serious. We understand today that a lot of boiler operators, maybe a lot of boiler rooms, may have one operator there at all time. And if for some reason, if something occurred, boiler shut down, they're forced to open up the rear of this boiler. Can one man open that very, heavy door?
Yeah.
I mean, a door this size, you're probably looking at 12,000 pounds.
Yeah.
So take a look in the near future, competitors on what they're using for their support structure. Number one, for that anchor point, bearing system. Guys, you literally, whether I have a door on here or not, this is how free this door will open and close. Yeah. And it's just a wonderful thing. So when I open it, I don't have that sensation of the door dropping.
Right.
You don't have a droop.
Yep.
Because that's a problem. If you're one guy out here trying to close this back up and you don't have a structure like this to support that heavy door, you're going to have to find floor jacks or maybe some sort of a overhead to help bring that weight up, set it back into place. You won't have that with this system.
Well, you think about, like in our situation with the rental boiler, the trailer's off the ground, and if you don't have something like this, and I can remember back in the day when we'd have the forklifts come in and all that, but literally one guy can do it and can open the boiler up, and that makes it so much better for the customer, I know, and even for our technicians that are out on site. Safety, the whole deal. It really works out well.
It really does.
Well, I think we're moving on to stage 3.
Stage 3.
All right, let's go. Okay, now we're on stage 3 in this process. So what is happening here?
In stage 3, this is where we're now going to enclose the pressure vessel with our front and rear smoke box area. So that would incorporate the frame, the davit, doors, all the refractory. Here you can see we've already staged the anchoring for the refractory that'll go in this rear part of the boiler. Also, at times, the pulse line number 2 and 3, we will do our first hydro for the pressure vessel to make sure everything is sealed, whether it's tubes, whether it's our connections, everything to that boiler, it's part of the pressure vessel.
Okay. As far as the refractory, that's all gets poured in here?
It's poured. We actually have frame models that we use that will incorporate in here, and they'll pour it from the top, and actually go in and they'll bead that in, put a beader in there to vibrate that and make sure we take care of all the void pockets. So everything is nice and full, no gaps whatsoever with that process. When it cures, then we're able to pull that frame off and see a final product with the refractory.
So probably something that people would want to know is the refractory. Okay, why is it even needed?
On a dry bag boiler, it's the heat barrier to protect the raw material of the pressure vessel. Okay, we're trying to keep that high temp because when it's coming out of this end of the furnace, you're talking 2,000 degrees. Okay, that's coming to the end of this, what we call a turnaround section of our rear smoke box. Right. So that reverses the flame into that. So it's critical on a dry bag boiler to have a good refractory that can withhold and keep that temperature away from that raw plate and keep it inside the boiler on into the tubes. And the door also has refractory on it as well. The door will also be fully refractory backed. Okay. All right. Are we ready for stage 4? Okay. Anything on the front of the boiler? Let's take a look. Okay. Let's take a look. So we've come around to the front of the boiler, and there's a few things you want to touch on this. Yeah. With a trailer type unit, we were able to help establish a nice outlet for the boiler. Typically on a regular Firetube boiler, you would see the flue gas outlet on the top center, 12 o'clock, on top of the boiler. Yep. But on this unit, we needed an exit to the side of the trailer to where you can now attach to a stack. Sure. To allow the flue gas to leave the boiler safely. Yeah. So pretty flexible on when you guys are building boilers, if you needed to stack over here or absolutely up top, you can do that. Yeah, okay. With all the sides, our standard Firetube products, we also build HRSG waste heat recovery units. Those are all custom designed specifically for that application, which we don't try to utilize a standard boiler for a waste heat recovery because we realize it's specific for its actual condition. So that's one thing that we're very strong in. Our depth with our thermal group is very, very good. So we're able to create, non-standard, non-typical type designs to satisfy a customer need.
Yeah, it worked well for us to be able to go out the side. So anything else here? Any insulation? Anything that goes in?
Yeah, all this, while we're doing this section here will be a 1-inch insulation that we'll put in.
Okay.
We encapsulate that or encase that insulation. The old days, we used to use a wonderful product called rigidizer.
Yes.
So either spray it on or roll it on.
Right.
Well, sometimes you get a nice even coat. It'll last for a while, maybe a year if you're lucky.
Sure.
But with flue gas velocity, it's amazing how that will erode that important insulation, because if that is gone, gets blown out your outlet,
Yeah.
you have nothing protecting, that raw material. So that flue gas stream will cut that material like a cutting torch over time.
Sure.
So with that little thin 1-inch or thin wall metal sheet that we put across that, it just protects that insulation throughout its operation without
Awesome.
any concern.
Yeah, it makes
And
total
then
sense.
Victory, we do fully insulate our boilers with a stainless steel lagging as well. I think very proud of our product. It's a very beautiful,
Yes.
well-finished product, and we're glad that we're able to provide that in all of our products.
Yeah, no, definitely very, very good looking, and something that we really like in our rental boilers, having that stainless jacket. 'Cause we don't have to paint.
worry about it. Yeah, that's
So,
right.
all right.
Absolutely.
Well, let's move on to stage 4.
Stage 4.
Okay, so we're at stage 4 now. Actually, in stage 3, I know that they put those doors on, and then they're moving over here to stage 4.
Yep.
So maybe walk through the process now. We got them on.
Well, what we do just to make sure, because again, you're dealing with a very heavy door when you're looking at a 2-pass design. That entire door is full of refractory. Very heavy steel to be able to support all that weight as well. So you're talking 10, 12,000 pounds of weight here that this arm has to support.
Yeah.
So when you pull that away, we want to make sure that when it's in the field, we want to make sure that if for any reason, if the anchoring point to that davit had failed, we still have another safety net by incorporating this safety cable
Yeah.
to ensure that even though it may drop some, if we lost that, it wouldn't fully fall off
Following somebody.
and land on top of an individual.
You can imagine up inside of a trailer, and where does the guy go? I mean, he's
Absolutely nowhere.
He's done. And I remember walking out and actually looking up and looking at the door of some of the older boilers, and I mean, it's literally a threaded bolt. And you know, even if you have all this stuff, if you just have a threaded bolt,
Every time,
everything is, I mean, it's
every
moving.
time you're moving that, you're cutting that material.
Yeah, yeah.
Right,
And
at some point.
I just love the design. I know that we had talked about that with you guys, and we actually had one of our service technicians that a door did come off at a customer site, and fortunately he was okay. But man, we started thinking about that, going, my gosh, all these years, and some great innovation there. Love that for the safety. What else you got here on stage 4?
Biggest thing is just really talking about some of the features, safety features again of that product, the maintenance ability of that product. I can't stress that enough.
Yep.
About the ease of opening them, our manway, handhold plates, being able to get access to the proper areas of the lower section of your boiler.
Yep.
If you've got any kind of routine maintenance to remove sludge or repairs. One thing that I meant to say in stage 1 when we were talking about our tube layout, we pay very close attention about how much gap we leave around the furnace
Okay.
and then on the outside edge of those tubes,
Yeah.
because it allows you to be able, if you, for some reason, if you had to replace a tube, I like to eliminate having to remove too many of the tubes unnecessarily.
Sure.
To where if it only takes 1 or 2, you can drop them off to the side, outside, or
Yeah.
in the inside, allow them to fall in at the bottom section and be able to pull those out if it ever happened.
Right. That makes
So
sense.
those are the things that we paid attention to with the serviceability of a product.
Okay. So you got 5 stages. We're on 4, and so let's move on to the 5th and see what we got.
Okay.
All right, so we are at stage 5, final stage. Everything is getting buttoned up and getting ready to put a little bit of a fire in there.
That's right.
Right?
Yep. Now that we've got all the piping on the boiler, the required piping that's required for this specific project, all your water columns, blow down piping, your control panels, your pressure switches, and then also incorporating the burner system now into this system.
Okay.
So now in stage 5, this is where we now allow the final wiring of all these components. Then we're going to get electric power to it to be able to qualify and test all the, the landings of all these items that are set up on this boiler. Check our safety interlocks to make sure everything is seeing each other. Prove out a fire. If a customer would like to see this boiler lit off, making sure everything is going to start.
Yeah.
This allows in this stage to do a low fire test.
Okay.
So that's satisfying a pilot and a low fire flame.
Okay. Now, if you want to get this thing started up here, you all actually can do that as well.
Absolutely.
Right?
We have a
test.
full-blown function test facility here at Victory. So we can pipe this thing up, provide deaerated water, chemical treatment, blow down, everything to where we can create loads on that product to be able to test it from 25% all the way to 100% firing rate.
Okay.
As high as 82.5 on a Firetube boiler, 82,000 pound per hour boiler.
That's incredible.
Yeah.
Awesome. All right, well, I think we've covered everything. I hope you enjoyed it. Oren, thank you very much for all that you guys do and take care of us. And we'll see you next time on The Boiling Point.